Hi everyone. Today I want to show you a new sensor that I've been working on. You may recognize this module. I've been using that module for a Bluetooth gateway. Today I'm not making a gateway. I'm making a device with the module. The module, as I mentioned before, is a multi-protocol module. So I'm going to be going through the different protocol that the module supported. I'm going to start with Bluetooth BLE. One thing unique this time is I'm not going to power the device with battery or DC power. Today, we're going to be harvesting energy from a waste energy. In this particular demo, I'm going to explore using thermal electric generator. There's a couple couple thermal energy sources. One is called TEG, thermal electric generation. The other one is thermopile, which is basically a bunch of thermocouple hook up in series together to generate enough power. So there's going to be a few cutoff in the video so that I can move around and set up the demo. So I'm going to pause for now and then come back and show you one of the demo. Hi everyone, I'm back. So I apologize if the video a little bit shaky because I'm going to use one of my hand to show you around all the components. Okay, let's start with, this is how the thermal generator thermal electric generator look like. I have a thermal paste, so it looks like that. Okay, so I already hooked it up to the sensor in here. No battery. You don't need this is my 3D printer. You don't need that to power the device, but I use this for testing so I can get some heat to test the device to harvest the energy. But the way you use this is not you dedicatedly power it with a heat source. You use it with waste heat. So I'm planning to use this. I'm gonna hook up a probe so that I can install it on my barbecue smoker. The way this thing works, the reason that I can do that is because of this work as long as there is temperature differences between the top and the bottom layer. As long as those two have two different temperature, it keeps generate energy. So in the case of barbecue, for example, you could put it on the door. I mean, I don't know whether you're familiar with Smoky Mountain Weber smoker. So you have the door. You could attach the heat side of the tag into the door, and then put a heatsink on top of it, and you'll get all the resources that you need to do a measurement to monitor temperature inside your barbecue smoker without any battery at all. And the other one is a thermophile as a source. Okay, this one, they both work principally the same with a Seebeck effect principle. But this one, you're gonna have to put it on the fire, high heat. It will generate about 750 millivolt of power. So yeah, without further ado, let me start the demo with the tag first. Okay, I'm gonna put the paste here, put it on top. It's a heatsink, okay, and the module down there, okay. And I'm gonna start my, before there, this is the, for those who follow my work on Bluetooth gateway, this is the gateway that listening to Bluetooth advertisement. The module will start advertising when it's turned on. Right now, it's not detected. It says not present because there's no power yet. So I'm gonna start heating up. So it's not instant. So because of we need to heat up the bed. We're gonna heat it up to 40 degrees Fahrenheit. Okay. And we're gonna go back to the computer. We're gonna wait and see when this change not present. Okay, it'll take maybe a couple minutes or less. So as the bed heat up, it'll generate energy, power, electric power to power our sensor. Yeah, we're gonna wait. There you go. It started. And the microcontroller has a built-in temperature sensor, so I may as well show it. I mean, I want to show something that it does something, so it's measuring temperature. And the other thing that it come later on the demo, you'll see that the voltage become important. But for now, it's measuring the input voltage. It's generating 0.38 volt or 380 millivolt. So okay, there you go. So one thing I want to show you is that the heat that is needed is not a lot. Let me touch the bed. See, it's comfortable. 40 degrees Fahrenheit is nothing. Oh, sorry, no, not Fahrenheit. I'm sorry. This one is in Celsius. So this is a 40 degree Celsius. And the room temperature is 19. But the difference between this and the bottom side is less than 10 degrees Celsius. And that's enough to power a sensor, especially for a Bluetooth low energy sensor that does temperature measurement, all that stuff. So again, I'm not looking for a use case where I dedicate a power to power the sensor this way. This is just for testing. For me, this is probably going to go into my smoker. When I start the smoker, there's a heat inside the smoker. The temperature outside the smoker will be cooler. Definitely, there's a lot of temperature gradient there. The difference between internal temperature of the smoker and outside will be a lot. So will be a lot more than a touch here. So I'm very optimistic that that use case will be easy to accomplish. Basically, there's no problem doing that. Now I'm gonna stop the video. I'm gonna move downstairs and show you doing the same thing with thermopile. Hi guys, I'm back. So I have installed the thermopile to the sensor, and right now I'm wiring it into my gas stove. So I'm gonna well, let's go back and check it's not present, there's no heat. We're gonna start with that, and we're gonna start the stove. Okay, turn it on. Okay, let's wait for it. It'll start generating power. It's a little bit different, this one from the other one. First, as you can see, you have to burn this one. The other one, it just need a temperature gradient between the two surfaces. Okay, so it'll harvest whatever energy coming in. When it has enough power, it'll gonna start the sensor. It takes a minute too, at max. Yep, there you go, present. And you could see the voltage. It's let me show you how it's supposed to look like. You put it right on the flame so that eventually it'll become like red hot. And this is how your fireplace has a thermopile, and this is how it works now. So you could see here, okay, the voltage is 0.4 volt. Now when the state is on, in this use case, you know that your gas stove is running. When the Bluetooth is off, then you know that your stove is off. Now the thing is, if we depend on that, the issue when it's ramping down, I'm gonna start doing that. I'm gonna shut off this. It takes a while before the sensor power off, but as I mentioned before, the voltage here, the reason that I have the voltage is you could see the voltage gonna go down quite rapidly. Before the present is off. You see the voltage, it's dropping. When you see the voltage dropping, you know that your stove is off. You don't have to wait until the presence to turn to like not present. So I mean, we can wait, but I'm not gonna let you wait until that long. I'm gonna turn off the video recording. I'm gonna set up the next demo. The next one, we've been working on Bluetooth so far. I've been demoing Bluetooth capability of the module, but the next one we're gonna be doing Zigbee with the same module. Let me shut off. Hi guys, welcome back. So here's my fireplace. We've been talking about thermopile, the last one. That's lit into fireplace has thermopile that run the valve. Just briefly to get some concept of it, basically the flame don't know whether I can. Oh, I couldn't focus on this. Okay, there is a flame there that generate power for the valve, and it uses very small power from the flame. So we're gonna use some of that energy to power our sensor. This time I make it a Zigbee switch. This version will have, if you can see these two capacitor, is a larger capacitor because of Zigbee is more complex protocol, so it need more power. And I built a custom switch here. We want to save as much energy as possible. So the way it works is there are 3 terminals in your valve, and they hook up directly to the sensor. 2 of them is the thermopile that generate the power. So in parallel, we'll go pull power from it to the sensor. The sensor will harness the energy, the extra energy that is not used. And then there is one terminal that is controlling the switch to turn on and off the fireplace. In this case, I'm again using Zigbee. I'm going to show you guys that I can turn on and off the fireplace from our hub. This is a normal to our hub. Oops. Let me turn off the light so that it can see. On the hub, it looked like a Zigbee switch. Basically, it's just an on and off. Okay. Let me go into on. And I'm gonna click on the on. Okay, there you go. It started the fireplace. With this, you will never need to replace any battery. The sensor is powered from the fireplace thermal energy. Just enjoy a little bit, and then I can turn off. If we go back in here, you can see that it's on. Okay, let's turn it off. Okay, so the other thing that I'm doing also is that I'm again reading the temperature. We do have some spare power to read temperature so that you could get some idea how hot it is around the sensor area. And one thing that I want to show you, okay, I don't know whether I can focus this. Let me try. Okay, remember that MAC address. Let me see if I can zoom in. Okay, there you go. Now, okay, that's a Zigbee. But the module itself, if you go back here, here I have that. It is also a Bluetooth device. It just happened not present at this moment, but so the module itself will work as Bluetooth as well as Zigbee at the same time. So and this is just a prototype. We're just scratching the surface of what possible to do, and I'm not considered done. I mean, I'm gonna have to run through a few more board. I think the idea is for Zigbee especially. I think for Bluetooth advertising, there is really no need to use any battery. We are efficient enough to power the sensor without any huge battery or huge capacitor. Now, for Zigbee use case, I'm designing something that, yes, it draw power from this waste heat, but I'm gonna give a backup primary battery in the case where, I mean, for some reason, you need it. For example, when the power is off and all the repeater is gone, and Zigbee has typically looking for, has a algorithm to look for new parents, and the energy that generated from the heat probably not going to be enough for long term looking for parent. So battery backup in that case is probably needed. But even with the battery, because of the main power is generated from waste energy, like in this case heat, you probably would not need to replace your battery for the lifetime of using the sensor, because of cases where you out of power, things like that. It's probably rare. Even that happen, the sensor itself is quite efficient. And the other thing is the power generation part of it, which is I'm primarily looking at the using heat, waste heat, to generate the energy. But I mean, as everybody knows, another common part is solar energy. And what I'm interested on is, if you're looking at what the input is so far in this demo, is a very low voltage. So I'm thinking getting something like a low power indoor solar energy rather than outdoor. So your light is enough. You know, in the old time when you're using calculator, there's some calculator that use solar power. That kind of solar power, maybe not that small size, but the concept is not outdoor solar panel, which is where you have a lot of energy. The other thing is, I know that a lot of people needs relay. We could probably control what we call bistable relay, where you could, in either state of the relay, it doesn't consume power. It just consumes power when you need to switch transition between state. So with the ability of harvesting energy, storing it, and turn on and off, use the energy only during the transition period, we probably could have some switch that probably does not need any battery. But I'm still looking for those scenario to solve. But at least for monitoring your stove, for barbecue thermometer, and controlling your fireplace, I'm pretty close to have a solution. It's the software is there, the hardware, the adjustment, the capacitor, setting, all that stuff is there. We just have to finalize the board and hopefully, if things goes well, it's something that I can share with the community. Okay, that's all for the demo today. Thank you.